Oh, grade 11s, and welcome to the second recording of the video I did yesterday. Alright, so today we're going to be doing the last section of air. Alright, so air pollution. We're going to be looking at methane emissions and ozone depletion. Nothing absolutely crazy, but actually quite interesting, I must admit, and also quite important. So, methane is a greenhouse gas 23 times more powerful than carbon dioxide at increasing the atmosphere's temperature. So, as much as people moan more about carbon dioxide than anything else, it is important to recognize that methane does exist, and it exists in quite high amounts, but not as in high amounts. Well, and not high enough amounts as the same as carbon dioxide, but high enough amounts to actually cause a little bit of a damage. So if there is any methane, it really does have a bit of a big problem with the atmosphere, but we're going to talk about what it actually does. So if you need to know the chemical equation for methane, it's at the bottom left hand corner of this PowerPoint. It is CH4. It is also extremely combustible, and it's also known as stuff like fart. Okay, so methane is also fart, and to a large extent anything that does fart is going to release a lot of the stuff. So there's natural sources of the stuff, so we're going to be looking at not necessarily artificial and natural, but more like man-made and natural. Okay, so the most prevalent natural one is of the wetlands, and we'll be doing wetlands in the next section of work. So wetlands contributes about 76% of all the methane that is released from or into the atmosphere, and this is because of the bacteria that is actually inside of the wetlands that is able to decompose all the dead and decaying matter, as in like fish and or plants and insects that will eventually then be released. So it is the same as how we produce methane, but our body itself doesn't produce a methane. It is more so the bacteria that is inside of our gut that is producing this methane as a process of some sort of biosynthesis. Okay, so they're breaking down substances in very anaerobic environments, and those anaerobic environments leads them to be producing a lot of methane gas. Then we have termites. Yes, termites. How impressive is that? Termites contribute approximately 11% of all the methane that is released. Then we have the oceans, and we have the hydrates, which are these sort of volcano-like structures at the bottom of the ocean that release a lot of methane gas as a process of breaking down certain substances, and those certain substances are actually able to be released, and many bacteria actually can use this methane to actually produce some carbohydrates in a process very similar to photosynthesis, but instead we call it chemosynthesis. Okay, important. You need to know the word chemosynthesis. So they can use this methane as much as some of them produce it. Some of them can use it to actually produce some carbohydrates in very, very specific conditions. So let's look at all natural and man-made amounts of methane. So over here we have the percentage annual contributions of methane emissions from different sources. And the reason I show you this is because I'm going to expect you to remember at least 3 or 4 main areas that methane is produced, and I'll like focus on ones that are slightly more important as well. So the main one we have over there is rice growing. Yes, and remember that rice is actually grown across the entire world, specifically in the Asias, and the Asias are, you know, where a majority of the world's population actually lies. So the amount of rice that they need, because it's a basic carbohydrate source, is extremely high. So they need to produce lots and lots and lots of this rice, and if you need to produce lots of rice, you need to have lots of space for rice. So if you are taking up lots of square meterage or square kilometerage of all of the world's like land to produce rice, you're ultimately going to you're going to be producing a lot of methane as well. Okay, and they grow them in something called a rice paddy. I expect you to know that word, a rice paddy. So they grow them in these waterlogged environments, and those waterlogged environments create anaerobic environments where bacteria are able to produce loads of methane, and we'll see pictures in the next slide. Then we have natural wetlands. As we spoke about it earlier, we have this bacteria, we have all this stuff, and a lot of the time you don't find a lot of moving water through these natural wetlands as well. There is water, but a lot of it is waterlogged. Okay, so the soil is completely saturated with water. The soil is extremely fine, so it holds onto water as well. It's very clay-like, and a lot of like biosynthesis happens over there, which allows for a huge amount of natural methane to be produced. Then we have the enteric fermentation. All right, so this is digestion inside of cows. Okay, so cow digestion, and we're talking about their farts. All right, so remember they have multiple stomachs, and in those stomachs they chew a lot of grass, and that grass needs to be broken down, and one of the ways is actually to involve a lot of bacteria inside of your gut like we do that breaks down all those substances and can release a lot of ATP for the body to be able to use. Okay, on top of it, you're going to get a whole lot of vitamins and minerals, so it is important to have this. But with increased production of cows, or like farming of cows, we have increased the amount of methane gas. Now, what is also weird is we've also recognized that you see the next one, which is biomass burning in the green over there, but we can actually try and collect this methane gas from the cows, and you've had some because it works as a really good alternative source to fossil fuels. So a lot of or some farmers, especially in America, there was one famous guy in South Africa as well. He was actually putting tubes up cows' bums, and or like putting these huge domes over these cows and trying to extract all that methane and putting in these huge like air bladders. So like imagine a big balloon just filled up with methane gas, and then he would like pump that into his house and he would burn it, and that would be his source of fuel. Then we have termites. That's not really that important, and then landfills, which is extremely important, and we'll delve more into landfills when we get into solid waste or land waste. Landfills by definition is just an area of land where people throw a lot of their waste products, and this is organic and inorganic, and a lot of that organics or substances and or products are then broken down by all sorts of microorganisms, including funguses, and that releases a lot of methane gases. On top of it, we can't break down any of that landfill because of the different types of dangerous chemicals that are in there. There's also very strong acids, and there's also chemicals that are going to stop microorganisms from breaking down certain substances in the landfills, which causes just a large amount of methane to be produced. Then we have mining, gas, and drilling. What you'll find is that a lot of these gases are actually locked into rocks and certain structures in the earth, and this is, well, there's a certain mining of gas called fracking, because a lot of people recognize that we need alternative sources, and South Africa was one of the forefront people trying to express how we can actually create different alternative fuels, and one of the ways was actually to involve fracking. But fracking is extremely dangerous and actually can damage entire ecosystems within months. So what they do is they drill into the ground and they extract all of that gas, but while they're extracting it, the amount of damage that they do to the environment around by clearing out trees, clearing out animals, and also just the chemicals that they use to try and trap the gas can be extremely dangerous to the environment, causing even more damage. And then finally we have oceans and freshwaters, which we're not going to focus on too much. So this is what a rice paddy looks like. The way that these are grown is extremely interesting. So it kind of goes in 2 wet seasons. So initially the ground needs to be extremely moist and waterlogged, and they plant all these little seeds, and then they grow in mass, and then they when it starts to dry out, they take each one of those little plants out and they replant them a distance away from each other, because they require a bit of like give and take on either like front, sides, and back, and then they start developing again, and then it rains again and it floods, and when it floods, these grass, or these, it is technically a grass, these grasses and rices are allowed to grow, and as they develop and grow, the amount of fermentation that's occurring at the base of the water in the anaerobic environment is causing a lot of methane gas from, again, these little microorganisms. Also, the amount of like what do you call this stuff? Organic fertilizer that they add into this entire thing is also very high, and that is what you are able to recognize as causing a lot of fermentation. Alright, so let's have a look at ozone depletion. This is probably far more important than methane emissions, even though methane is extremely dangerous. So, ozone depletion is very important because we're creating holes in the gaseous layer that allows a lot of our heat to be regulated, that goes in and out of the Earth's surface. Okay, so if we have a hole, that means that we can allow a lot more UV rays inside, and if we can invite a lot more UV rays, that ultimately means that we can heat up the surface of the temperature of the Earth. And the way that the surface actually increases is not necessarily just by allowing the UV rays in. The UV rays have to be absorbed by certain substances. So some of those UV rays are actually bounced off of that ozone layer and go back into space. Whereas if some of them get inside, they will be absorbed. If they are not absorbed, they will bounce off of the Earth's surface. When they bounce off of the Earth's surface, they will either go directly outside of the ozone layer, or they will be reflected back onto the surface of the land. Now, if you do this process where it enters the surface but does not get absorbed, and you keep on throwing more and more sun rays, eventually some of that UV radiation will be absorbed. And if that UV radiation is absorbed, it's then going to will cause an increase in the average temperature of the Earth. Now remember that the average temperature of the Earth cannot go up a lot. Maximum, I mean, we're talking about 5 to 7 degrees Celsius. If it it's like a fever, you know, if your body goes up by 0.5 to 1 degree Celsius, you're experiencing a fever and or hypothermia, you know. So certain areas are getting colder where certain areas are getting warmer, and this is causing really, really big dangers. So let's talk about the ozone layer itself. So you can see I don't expect you to know where it is in terms of this. So I don't expect you to know the troposphere, the stratosphere, or the mesosphere. I just need you to know it is sort of quite high to the surface, or to the outside of our entire atmosphere. Remember the word atmosphere, or atmos meaning gas, and sphere means like circle of, so circle of gas around the Earth. And that ozone itself is made out of O3. So you know oxygen as in normal stuff that we breathe in is O2. So there's 2 oxygen molecules bonded to each other. Ozone is O3. So it's 3 oxygen molecules bonded to each other. Now, O3 or ozone is not a very stable compound. It wants to bond with absolutely anything. It shouldn't naturally be in that weird state, and because of the strange temperatures and radiation that is present at the surface of the atmosphere, that is what causes this ozone layer to actually form. If you had to breathe in ozone layer, you would suffer from serious respiratory cancers, because ozone tends to bond to everything. Remember that oxygen is very much, you know, it just wants to bond with everything. It's a bit of a whore in terms of how it wants to really relate to all the other molecules, and when it starts bonding with things, it can start ripping apart your cell membranes, and when it does that, it can start causing cancers and or cuts and lesions, and it really can do a lot of damages, and these are called superoxides, and this is just one of them. But because this ozone layer itself is so unpredictable and so volatile, and you know, it's unstable, it wants to bond with everything, and there are a couple of things that I've mentioned over there called CFCs, HCFCs, halons, and methyl bromide. Now those 4 different gases like to bond with ozone, okay? And when you bond with the ozone, you're going to be pulling away one of those oxygens. So now it's going to damage us if we breathe it in, but it's also keeping a lot of the sun rays out of the Earth. Now, if those certain gases that I mentioned earlier bond with the ozone, it's going to turn it into normal oxygen, breaking apart the ozone layer. If it breaks that ozone layer, then more sun rays are allowed to enter quite substantially, okay? And now let's go through what each one of those are and what they do. So we've got CFCs and HCFCs. So CFCs are chloro, CHLORO, fluoro, FLOURO, carbons, okay? So chlorofluorocarbons, and then we got the HCFCs called the hydrochlorofluorocarbons, and these are used in aerosols, refrigerants, and air conditioning. Now, thank goodness, to a large extent, we don't have a lot of these CFCs and HCFCs in our atmosphere anymore because of certain protocols, which we'll go through a little bit later, that have been put in place so that we start phasing out these certain gases. My brother-in-law actually deals with a lot of refrigeration, air conditioning. I spoke to him about it the other day, and he was saying that they have changed the gas that they use, but what they haven't told a lot of people is that the gases they are using actually can potentially do more damage than the actual CFCs and HCFCs. Then we've got the halons, which are found in your extinguishers, and finally we have methyl bromide, which is an agricultural pesticide. So remember that agricultural pesticides, we're not spraying like a small part of the land, we're spraying an extensive part, and that tends to aerate quite quickly, which means that it gets put into the atmosphere, and that floats all the way up as it increases in temperature, hits the ozone layer, starts bonding with it, the ozone breaks down, and now we have a huge hole above ourselves, okay? We'll also might go over the bouncing of the sun rays a little bit later again. Now, this is the ozone depletion itself. So we have letters 1, 2, 3, and 4. So we can see that 1 over there, the CFCs are released and they start bonding with the ozone layer itself. Then in 2, as it bonds, it causes the ozone layer to break apart and float away from being held together by the ozone layer. Number 3, a huge hole opens up, and that hole will then, a whole bunch of things can happen. So then in number 4 specifically there, the UV ray is being absorbed directly onto the Earth's surface. Now, there is a sun ray at the top left-hand corner over there, and that is where a UV ray or ultraviolet ray is being bounced off of the ozone layer. So part 1, it can be bounced off of the ozone layer. Part 2, it can be pushed through the normal ozone layer and absorbed by the Earth. 3, they can go through the hole and be absorbed into the ozone layer. 4, they can be moved through the ozone layer. It will bounce off of the surface of the Earth and it will leave the ozone layer again. Number 5, it will be entered either through the ozone layer or the hole. It will be bounced off of the Earth, but then it will be bounced off of the ozone and back into the surface of the Earth to increase the probability of it actually being absorbed by the surface of the Earth. Okay, so the ozone layer can bounce things off of the top of it or off the bottom of it. Either way, ultraviolet rays can bounce around. So let's look at some of the problems or the effects of ozone depletion. We can have an increase in skin cancer, because remember, UV rays, if they bombard our DNA, can actually cause a mutation, which will cause a tumor growth, and that tumor growth will be a cancer, and that specific skin cancer is known as melanoma. Number 2, increase in cataracts. So your eye can only handle so much UV radiation, because remember, as it's collecting all of the light rays, it's also collecting a lot of UV radiation. That's what ultimately allows you to determine whether it is day or night, okay? And we'll do that a little bit later at the end of this year. But if there is too much sunlight, the eye starts to worry because you can damage the nerves at the back of your eye. Sorry about that. So they start creating this layer on the front of the cornea, and that actually causes like a barrier which stops light from coming in. However, that barrier doesn't allow, if it doesn't allow a lot of light through, it means that it's actually going to also allow you to become blind over time. However, the cataracts can be cut out, but it's not necessarily something that is very cheap and many people have access to. Then we can have the increased incidence of malaria. This is because of the average temperature of the Earth increasing. That means that not malaria will survive, but the vector that carries it, the Anopheles mosquito itself, that will be able to survive in bigger areas because now those areas are warmer. Okay, and if they are warmer with a lot of moisture, they'll be able to develop, and because they will have access to areas of people who did have malaria, they will move that malaria down further south and or further north, depending on where the global warming is occurring. Number 4, we'll have a change in life cycles of plants, and this is because, remember, certain plants start flowering in winter and some start flowering in summer, spring, and or autumn. And depending on the increase or decrease in temperatures, that could shift when the plant actually starts to produce its flowers, and that can ultimately affect when it starts producing its fruit. Now, if you are a farmer or someone who is in agriculture, or even in horticulture, you want your plants to grow at certain times of the years, and you have to understand when those plants are growing so that you can get maximum amount of yield. If that now changes because the plant is developing at different times, the whole economy around agriculture needs to change. So the change in life cycles of plants has huge impacts. Then we have change in wind patterns, because remember, wind is formed by a hot air moving past cold air, or just like two sets of airs moving past each other, and as they move past each other, they cause wind. So if you're going to increase certain parts of the Earth, that means you're going to either increase and or decrease wind. Then you're going to have the slowing down of photosynthesis. Remember last year when we did photosynthesis, I mentioned that one of the factors that affects how fast photosynthesis occurs is the amount of UV radiation, or amount of light. And this is because you must remember that with increased light, increased temperature, and that temperature will ultimately cause the chlorophyll to denature inside of the plant, and if it denatures, that ultimately means that there's not going to be any photosynthesis occurring, which means that the plant can die, okay, because it's not going to be producing any carbohydrates for itself to survive. So this is just a brief look, and please, you don't have to learn all of this. This is just for you guys to see that in 1987 we had something called the Montreal Protocol. So this was the original part where the whole world came together and they had this huge, tea party where they decided that they needed to start taking out all the chlorofluorocarbons and the hydrofluorocarbons. And they turned around, they were like, you need to get rid of this. So a lot of the countries actually said, okay, fine, but it wasn't until 1989 where we actually started to phase out all of these different gases. Now, that is when I was born, so about 31 years ago. That is only when we started realizing we should actually do something about it. And then again, not even all countries adhered to this, so there was a lot of problems. Anyway, going on, there was eventually the Kyoto Protocol, there was the Bangkok meeting, the Beijing Addendum, and then finally the Kigali Amendment. And this was where now they're saying you really, so the first one was more like CFCs, now we need to start getting rid of the HIFCs. And this was just, it's certain gases that were affecting it. But something that was released probably about a week ago or a couple of days ago, where they're saying that the ozone that was, or the hole that was actually created over the Antarctica has finally closed. But now this is, as much as, all scientists are ululating, it's not necessarily a good thing, because a lot of those plants, animals, and just the general environment in terms of like non-living things like wind and water and stuff, that has changed and adapted to when there was a big hole above it. So now closing again, is this going to be any good or any bad? And it could just mean that there's going to be, with increased amount of UV rays, it means that more heat is actually going to be left inside. Okay, so this really is a bit of a hit and a miss for us, but I mean, it's quite interesting anyway. All right, so I hope that you guys can hear me this time, and you have a fantastic day. Cheers.